And before we get to that, I want to review briefly what we learned when we talked about addition and subtraction of like terms. Remember, when we were dealing with addition and subtraction, we said that our variable had to be the same and the exponent had to be the same. The fact that we have a 3x squared here is the coefficient just tells us we have 3 of them versus in this first term. Here we have 1 of them. We keep the like term of x squared together. Like terms get a little different though, when it comes to multiplication and division. When we deal with multiplication and division, all we care about is that the base is the same, the variable or the letter, not that the exponent is the same. So for example, if we have a squared times b cubed, because these are sitting right next to each other, we know it's multiplication. All we need to look at t is whether or not the bases are the same. We can't simplify this at all, so we can't simplify that if on the other hand, we have the same bases. So here we have base a and base a, they're raised 2 different exponents. We have a squared and a cubed, but because we're doing multiplication, all that matters is the base. And this should make sense to us, because if we multiply these together, we see a squared is a times a dot, and then we know a cubed is a times a times a. This simplifies to a to the negative 1 because 2 minus 3 is negative 1. And now we need to realize that a to the negative 1 is the same thing as 1 times a to the negative 1, which is the same thing as 1 times a to the negative 1 divided by1. The reason we put these understood ones here is because we want to make this exponent positive. And in order to make the exponent positive, we need to take this a to the negative 1 value and move it to the denominator. So when we move it to the denominator, we are going to be left with this understood one in the numerator. In the denominator, we are going to have 1 times moving a to the negative 1 to the denominator makes the exponent positive. And remember that that's always the case when you have a negative exponent in the numerator. You can make it positive by moving it to the denominator. If you had a to the negative 1 in the denominator, you could make the exponent positive by moving it to the numerator. And now this of course we can simplify to 1 over a because this understood 1 can be dropped and this understood 1 can be dropped. Well, we are going to deal with our excess together. So again, dealing with our x's here, we'll get x to the 2 minus 5 when we take the numerator exponent minus the denominator exponent. And that's the case because you can think of this here as essentially x squared over x to the 5th times. Now keep in mind that this is the formula you should use where you subtract the denominator exponent from the numerator exponent, you do numerator minus denominator. That formula will work every time and it's the safest way to make sure you get the right answer. But you can always just sort of logically double check yourself by remembering that the terms that you end up with in your final answer are always going to be wherever you have the largest exponents in your original problem. Because the 3 was larger, I knew that my term was going to end up in the denominator and it did because the larger exponent is in the denominator. In other words, if for example I was just going to deal with this x squared over x to the 5th, I could just take my exponents. So either way is going to work. You can just consistently take the numerator exponent minus the denominator exponent and you'll get the right answer. Or you can look for the larger exponent, subtract the smaller exponent to get your answer for the exponent and then put the term wherever the larger exponent exists.